Okay, this video is going to go through how to solve simultaneous equations using the elimination method and also looking at how the substitution method works. So the first method we're going to go through is the elimination method, and for that to happen you need two equations which are set up like this, where both unknowns are on the left and there are numbers on the right. Now the elimination method works by removing one of the letters from the equations, making it easier to work out the other one. So in this set of equations what we're going to do is to add them, and if you think of this as a column addition, when we do this we're going to add the x terms, then the y terms, and then the numbers, and we're going to see what we're left with. Now what will happen when we add these two is the y terms will eliminate. A good way to tell whether you should add or subtract your equations is by the signs in the middle. If they're different, so one's add and one's subtract, you should add them, and if they're the same you should subtract. Now when we do this with these terms and these y terms, we will be fortunate enough that they are going to eliminate and we don't have to do any extra work. So when we do this, the x terms add together and we get the 5x, and on the right we get 25, but the y's will disappear. If you think about what happens in numbers, if you add -3, add +3, that's going to give you 0, and so that's why these y terms are also disappearing. This then solves to give you x equals 5, and so we've already done part of the problem. The next bit is to work out the value of y. So now we know what x is, we use this to help us find the value of y. And you use substitution by putting 5 into the value of x in one of the equations, and then you can figure out what happens. So I've chosen the second one, and if I go through that I will find that y equals 2. And here are my solutions, x are 5 and y is 2. I can check this by substituting it back in to the original equations and see that it works. This can be helpful if you're getting answers which seem a little bit unusual. Now the next example is going to be a bit harder than the first one, and the idea is to try and go through a more challenging type of problem you could get. So here is the second example we're going to look at. Now unfortunately in this one, if I was to add or subtract these equations from each other, I'm not going to eliminate any of the terms at all. The x's and the y's will still be there. And the main problem is that when we actually look at these terms here in the middle that we eliminated before, they're kind of not the same. Before we had plus y and a minus y, so they were sort of similar and would eliminate. But here we've got minus 3y and minus 4y, so they don't match up. So the idea is to multiply one or both equations by any numbers you want to, so that these terms will match up a bit better. The easiest way to figure out what you've got to multiply by is using the lowest common multiple. So if you look at the 3 and the 4, the lowest common multiple of those two values is 12. So I'd like to get minus 12y's here. So this would then give us these two equations on the right. So the top one's been multiplied by 4, so everything gets multiplied by 4. And the same with the bottom one. Everything got multiplied by 3 though, because that then gives us the minus 12y. And so now you can see that we've got this minus 12y in both equations. Now this time, because the signs are the same, we're going to subtract so that we eliminate. If I add these two equations, we get minus 24y, and so it's not going anywhere. So we're going to subtract in this case, and like before, what happens, we're going to get left with just the values of x to solve, and in this case we get a nice value that x is 5 again. Again, so like last time, now we know what x is, we have to work out the value of y. So on the left, I've taken the second equation, substituted in, and done a bit of rearrangement and so on. Here we can see that y is a negative value. Don't be put off by this, it can happen. It could also be decimal, maybe even mixed numbers. You just have to be sure that if you substitute them back, they would work. And in this case, we could do that and it checks out okay. Now the last thing that I'm going to go through is the substitution method, and the equations look slightly different in this one. Typically you'll have one equation where both unknowns are on the left, and then you'll have another equation where you'll have one unknown on the left and one on the right. The idea of this method is that you will substitute one equation into the other, and it's usually the bottom equation going into the top one. So where you can see I've highlighted the y in blue, that's going to get substituted, so that y is going to disappear, and we're going to replace it with the red stuff, the 2x minus 3. This is going to give us an equation that looks like this now. Now I have put brackets around the 2x minus 3 part, typically because we're going to expand these brackets or we're going to do some multiplying, and I want to make sure that I multiply every term that needs to be multiplied. So this is usually a good way to make sure you do that. So by expanding the brackets, I'll get something involving just x's and numbers. I need to collect terms and rearrange a bit, but I'll gradually get down to that x equals 4. Now in this type of work, once you have got that first value, it's usually easier to get the second one because of the second equation that we were given and how it's set up. So using this one, now we know that x is 4, we can work out that y equals 5. Again, check if you want to, by substitution this works, but this is usually a bit trickier for some. Now this kind of problem can be made much harder. If I didn't have add 3y, if it was minus 3y, when I expand the brackets, I'd have to think more carefully about the signs that I'm dealing with, because there's a negative term outside the brackets and negative terms inside, so I need to think about what signs I would get. But hopefully this video has helped give a bit of a recap or a reminder of how these methods work and how you should use them to solve simultaneous equations. Thank you.